Hello, my name is Geronimo Mendez,
And I'm George Sanchez.
and I'm here to present for CECS 326, which is
The,
CPU scheduling.
the first algorithm that we're gonna present right now is the first come first serve, and this was basically just putting the task into a queue, and as the whatever comes into the queue first would be the task that would be executed first.
Okay, I would
And
like
this
to. Oh,
this algorithm is actually works really well with small burst times, as like the whole thing task has to be implemented before the next it can move on to the next one.
yeah, I would like to point out that in order to prove that this is indeed correct, I'm gonna show you how the tasks come inside the text file that we're gonna be running, and this is the order. We have to call the main function, the algorithm we're using, and also this text file. So as you can see, they're coming into the queue in this order. So once I go ahead and run it, George can go ahead and explain the rest.
So we went ahead and ran it, and as you can see, we compare with the text file. The queue executes each task first, and it waits till that task is done to execute the next one.
Yeah, so as you can see, task 1, 2, 3, 4 in that order because it was put in that order. So yeah, that's the very first one. The next one we're gonna talk about is the round robin. So let me go ahead and clear this. So round robin, I'm gonna use the same schedule. So go ahead and run it. So this one's a bit more tricky. So the way this works is that we have a 10 millisecond. Let me go ahead and show you for the round robin. We have a 10 millisecond time quantum, which is basically it's going to allow the first task to run for 10 milliseconds. And if it's not done, regardless of how much time is left, it goes on to the next one. So as you can see, T1 starts in 20. And since, it runs for 10 seconds and then it goes to task 2, since it's 25 seconds, it doesn't finish. These two have not been finished. It goes to the third one. It doesn't finish it. It goes to the fourth task, doesn't finish. Fifth task doesn't finish. But this T6, as you can see, runs for the time quantum. So this T6 will not appear anymore since it's over. Since the time quantum fits the order. T7 runs again, T8 runs again. And then finally, because it wasn't finished doing task 1 after doing the first round, as you can see, it now reduced it to 10. So as you can see, it used to be 20, but now task 1 is 10, and it was added back to the queue so it can go back to it. So as you can see, after this passing, T1 should not appear anymore. Just like T6 is not here anymore. After T5, you go to T7, and so on and so forth. So at the end, you run, let me show you the very last time. T1 is not here, so we start with T2, since it only has 5, T3 has 5, T7 has 10, and T8 has 5. This is where it ends because the next round, they all have been executed.
Okay. The good thing about round robin is actually the fact that you get to choose the I think the run times I was reading in the notes. So that's the priority over other algorithms.
Yeah, exactly. You get to choose the time quantum. And another thing is that you can also implement the priority for the round robin, which is another benefit.
Exactly.
Okay, and then that's a good segue for our round robin. For our priority. So this is a different scheduling algorithm, and we're going to go ahead and use the same schedule. So what you can see is that basically the highest priority, which is 10, gets ran first, even though it's task number 8, it goes first. T4, which is tied with T5 in priority level, they get ran second, and then so on and so forth. This is priority 4, so task 5. And I included basically this line of code as well to show you when the task has been finished, just in order to be kind of in accord with the go ahead and show you with the run text file that you provided for us. So as you can see, they match up perfectly. And yeah, it was anything you'd like to add, George?
Not really. I mean, it was a tough project, but I'm glad that we did it because I understand the algorithms a little more.
Yeah, actually, at first, this project seemed a little daunting, and it was a great challenge to actually go over and see the different ways that the CPU interacts with scheduling. And
Exactly.
that's it for now. Thank you.
Thank you so much.